Welcome guys to the YouTube channel. Welcome. Today we'll be focusing on geometric series. Like already spoke about what a geometric sequence is, and I've already showed the difference between a series and a sequence on the video that I made on arithmetic series. So if you need to know the difference between a series and a sequence, feel free to go back and watch that video. So we've said that on a geometric sequence, we understood that a geometric series or a geometric sequence involve what we refer as a common ratio. We have what we call the common ratio, so which is symbolized by r. And then let's just have a sequence that is a geometric sequence, a series 1 over 1 over 3. Let me make our first term as 1 over 3, and then let's make 1 over 9, 1 over 27. So this is our series. It continues 1 2 3. So this one is our sequence. A sequence is denoted by the commas like this. But since we are referring to a series this time, we're going to use a plus sign in between them. So this one will be a series. A series is the sum of all the terms. I hope you understand that. So now, in a geometric series, you have to know that the terms are separated by a plus sign, because a series is the sum of all the terms. Now, we have to know the formula that we use, the general term, the general term of a geometric series. The general term of a geometric series it's like Sn. Sn symbolizes the sum, since the answer you get after adding is referred as what? As the sum. So in the geometric sequence, in the geometric series, we are looking for what? For the sum. Sn means the sum of the nth term. Sn, the general term will be Sn is equivalent to a into r exponent n minus 1 divided by r minus 1, whereby r should never be equivalent to 1. The common ratio should never be equivalent to 1, because it will not make this formula make sense. Or somebody can say, I don't prefer using this formula. I prefer using the one that says Sn is equals to a into 1 minus r exponent n divided by 1 minus r, whereby the same thing apply. R should never be equivalent to 1. So guys, here these two formulas, you can use them interchangeably. So what I'm trying to say is that if you have r exponent n minus 1, it means that if you have r exponent n minus 1 in these brackets, the denominator must follow the same notation. It must be r exponent n minus 1 divided by r minus 1. If you have 1 minus r exponent n, you must have, in the denominator should be 1 minus r. Please do not interchange them. Don't have any case, we don't have a formula as such. Sn is equivalent to a into r exponent n minus 1 divided by 1 minus r. These notations should be what? Should be the same. If you said r exponent n minus 1, so you should divide by r minus 1. I hope I'm making a lot of sense there. So I've made it clear on the previous video that Sn is equivalent to Sn minus 1 plus Tn. What I'm trying to say here is that S1 is equivalent to the sum of the first term, T1. S2 is equivalent to the sum of the first two terms. S3 is equivalent to the sum of the first three terms, T1 plus T2 plus T3. But somebody can see that since we've said that T2 is equivalent to T1 plus T2. So, and here we have T1 plus T2. We can say S3 is equivalent to S2 plus T3. So guys, here you will use this formula in any case whereby you are given the the formula, the sum of the general sum of the term, um and they are looking for Tn. So you will be using this formula. You will see when we work on some activities, guys. So stick on this information, guys, and then you will be fine. Remember, a series involves the plus signs, and a sequence involves the commas or the semicolons in between the terms. And the general term for this one is Sn is equivalent to A into R exponent n minus 1. And then you can use this one or this one. Your teacher might say that you use this one if your R, your teacher might say you use this formula if your R is greater than 1. And then you use this one if your R is less than 1. That's what your teacher might say. But generally, you can use either of the two as long as you follow the right mathematical calculations, and then you will be fine. So I will be proud if we can just try to work on some activities that will show us that you might find in the examination based on geometric series. Sorry. So let's try to work on some activities. So the first questions, here we have an activity on geometric sequence series. It says determine the sum of the first 10 terms of the first 10 terms of the series. We have our series like this one. So how are we going to answer this question? We are looking for the sum of the first 10 terms. So what do you have to know in order to find the sum of the first 10 terms? You have to use this formula. You have to use this one or this formula. So let's try to use one. The formula says the formula says Sn is equivalent to A into R exponent n minus 1 divided by R minus 1. So what do you need in order for you to use this formula? You need to find the first term of the series, and you have to find the common ratio of the series. So let's work on that. So we have our first term as 2, our second term as 4, our third term as 8, our fourth term as 16. So now let's try to find, we have enough information to get the R. So we're going to say 4 divided by 2, and then we're going to have 2. We're going to say 8 divided by 4, we're going to have 2. We're going to say 16 divided by 8, we're going to have 2. So it means that 2 is our common ratio. Now we also have what? The first term. Our first term is 2. And then we have n. Our n is what? Is 10, because they are looking for the sum of the first 10 terms of the series. So let's go ahead and substitute. S10 is equivalent to, we substitute, what is the first term? Our first term is going to be 2. We're going to say 2 into 2 exponent 10. Exponent 10 minus 1 divided by 2 minus 1. Remember, our R is 2 and the 1 is in the formula. Then you use your calculator, you click this one. So let's use our calculator and work it out. 2 into 2 exponent 10 minus 1 divided by 2 minus 1. So it means that the sum of the first 10 terms of this sequence is 2046. So this one will be our answer. Guys, whenever you have a question that involves the sum, always stick to this formula. Try to find the type of the series that we have. Remember, guys, yes, I remember I've told you on the previous video that we have only two sum that we'll be focusing on, which is the arithmetic and the geometric series. So these are the two things that you should focus on. So let's try and work on the next question. For those who haven't subscribed yet, please click that button and subscribe to my channel so that you can get notified if I've uploaded videos like this one. So let's get to the next question. The next question says the sum of the first nth term of a geometric series is. So now we are given the geometric series. We have 3 over 4 plus 3 over 2 plus 3 plus, and then till the nth term, and then it's equivalent to 23 1 over 4, 23 and a quarter. So here we are looking for the number of terms that when you add them, they are gonna result to this. So let's try to work on it. We know that the formula says Sn is equivalent to a into r exponent n minus 1 divided by r minus 1. I prefer using this formula, this one, more frequently, guys. I prefer using this formula more frequently. So please get used to it. Okay, so now what we are going to do here, since we are looking for n, it means that the 23 and a quarter is our Sn. And then we have the first term. The first term is this one. This one will be the A. And then we have to find the common ratio, guys. So the ratio will be T2 divided by T1, which is equivalent to 3 over 2 divided by 3 over 2 divided by 3 over 4. And then we go ahead and click the calculator. We have 3 over 2, 3 over 2, 3 over 2, and then we divide it by 3 over 4. We get what? We get 2. The ratio in this case is 2. So the ratio in our case is 2. So we are good to go. We can find the value of the value of n now. So let's go ahead and substitute in the known information. So we know that Sn is equivalent to 23 and a quarter plus, which is equivalent to, what is the first term? The first term is 3 over 4. The first term of the series is 3 over 4 into, what is r? Our r is 2 exponent n minus 1, and then we divide by what? 2 minus 1. This is how it works. So we are just looking for the value of n. So how do we convert a whole number and a fraction to a single fraction? You're going to say 4 multiplied by 23. Let's go ahead and do that. 4 multiplied by 23 is 91, and then you say plus 1, and then you say plus 1, which is 90. Oh, it's 92. It was 92 and 93. Now we're gonna have 93 over 4. And then it's equivalent to, we divide by the denominator. We don't change the denominator. Remember, guys, in order to change it, you do what? You say 4 multiplied by 23, and then you get 92. And then you plus by the numerator, you get 93. You say 93 over 4. And then you work things out now. So we're gonna have 3 over 4 into 2n minus 1 divide by the whole thing. Divide by what? 2 minus 1 is just 1. So it means that you have what? It means that you have 93 over 4, which is equivalent to 3 over 4 into 2n minus 1. You can work out in anyhow using your mathematic strategies. So let's work it out the way I do it. So what I'm going to do here, I'm going to multiply both sides by the reciprocal of this coefficient of 2 exponent n minus 1. I'm going to multiply by 4 over 3 both sides. I'm going to multiply by 4 over 3 both sides. So what I'm going to have here is that I'm going to say, oh, this cancel this. It's going to be 31, which is equivalent to this erase this one, this erase this one, I'm going to be left with 2 exponent n minus 1. Use any mathematical trick that you know, and then you will get the right answer. You take 1 to the other side, you're going to have 2n is equals to 32. Again, you can use log, or you can express 32. You say 32 is equivalent to shift this one, and then you can express 32 into base 2, which is 2 exponent 5. Since the bases are the same, now you do what? You equate them exponent. It means that the number of terms that you're gonna add in this sequence, in this series, and then in order for you to get 23 and a quarter, they are just 5 terms. So that's how you work along things. So now, moving on to the next question. Let's try to move on to the next question. Let's try to move on to the next question. The next question says, determine the sum of the series. We are given this series. The last term of the series is this one. So let's write the series. The series is 3 plus 9 plus 27 plus 81 plus, and then we have our last term as 559,049. Guys, in geometrics, you are going to work with large numbers, and then they say determine the sum. We want to know the sum of all these. It means that we're going to use the formula as n is equivalent to a into r exponent n minus 1 divided by r minus 1, whereby r should never be equivalent to 1. Now, it means that in order for us to get the sum for this, we have to find the last term, the value of the last term. So how are we going to work out what is the last term in this case? So in order for us to work out what is the last term in this case, we are going to use, okay, we have the last term. We're going to use the formula Tn is equals to a r exponent n minus 1. That's how we're going to get the last term, because to get the number of term of this series, because we know the last term. So now our last term is, let's get the ratio here. The common ratio is going to be r is going to be equivalent to 9 over 3, which is equals to 3. Now, what will be this one? The last term is 59049, which is equals to a. Our first term is 3. What is our r is also 3 exponent n minus 1. So now it's going to be much easier for us to work along this question, because we have 59049 equals to, when adding powers of the same base, we keep the base and add the exponent. It's going to be 3n plus 1 minus 1. This one minus that one. So it's going to be 3 exponent n equals to 59049. And then how are we going to work this one out? We express this number in terms of what? Of base 3. Let's work along that number. We're going to have 59049, which equals to, and then we express it to base 3. It says it's equivalent to 3n is equals to 3 base exponent 10. It's equals to 3 exponent 10. So now, since the bases are the same, we equate the exponent, and then it means that it's gonna be 10, and it's gonna be 10. And then we go back to this one. We find what? We used this formula because we didn't know the value of n. And how are we going to know the value of n? We are going to know the value of n using this formula, because we have the last term of this series. So now let's go. We know a, r, and n. So it's easy for us to get what the first term, the first 10 terms of the sequence. A is 3 into 3 exponent 10 minus 1 divide by this one divide by 3 minus 1, and then we click our calculator from there. So we know that we're gonna have 3 into 3 exponent 10 minus 1, and then divide by 3 minus 1. So it means that the sum of the first 10 terms of this series will be 88,572. So that's how we can work on this kind of question. So let's move to the next question. They say the sum of the nth terms is given by, so this, in this case, they are looking for, they say determine the fifth term. The question says determine the fifth term. They are looking for the fifth term, guys. So how are we going to work on this kind of question? So I've already told you before that in order for us to, if you are given such a question, you are given the formula of the sum, and they are looking for T5, then you are going to use this notation. I've said it when I was doing the theory. I told you that you're going to use this notation because you have what? You have Sn. You are looking for T5. How are we going to do that? We know this notation that says if we have S3 equals to, S3 is going to be equals to S2 plus T3. It means that if I'm looking for T5, it's going to be S5 is going to be equivalent to S4 plus T5. Meaning that I have to do what? I have to find S5 using this formula and find S4 using this formula, separate them out in order for us to get what? T5. Let's work on that. So our T5, since we have 1 over 3 exponent n, it's going to be 1 over 3 exponent 5 equals to 1 over 3 exponent 4 plus T5. And then it's going to be simple that way. We take this one to the other side, and then it means that our T5 is going to be 1 over 3 exponent 5 minus 1 over 3 exponent 4. And then we click the calculator, we get our answer. So it's going to be 1 over 3 exponent 5 minus 1 over 3 exponent 4. 1 over 3 exponent 4. And then it gives us minus 2 over 243. And then this one is the value of what? Of T5. Please, guys, don't forget this notation. If you are given the sum, the formula in this, the sum of the nth term, and they are looking for a certain number, if they were looking for T100, we were going to say, okay, S100 equals to S99 minus T100, right? So you can see the notation, how the notation goes. So this is how we were supposed to answer this question. So guys, feel free to, if you have any question that you didn't understand, feel free to ask me on the comment section. I will gladly answer you. And and if you haven't subscribed to the YouTube channel, please guys, please subscribe to the YouTube channel so that I can keep making videos like this.